Hello and welcome to the part 2 video of Clasien Ester Condensation. In the last video we had understood what a Clasien Ester condensation is. We had seen the mechanism of Clasien Ester condensation, and we had understood what is the rate determining step. We had seen how to make the product from the reactants given, and in this particular video we're going to look at examples, and in fact primarily we're going to look at the mixed Clasien Ester condensation. When I say mixed, it means that we are going to use two different esters compared to the fact that we had used the same ester in the last video. So this is some kind of a cross ester condensation, crossed Clasien ester. So let's take some examples. If I take ethyl benzoate, now the purpose of the cross obviously is that we need two esters to combine with each other, so we must ensure that the esters we take are such that we get as minimum products as possible. In fact, if possible, we get one product only. So in that case what we do is, rather than taking both esters with alpha hydrogen, we take one ester which doesn't have any alpha hydrogen and take the other one with alpha hydrogen. So here I'm taking this is ethyl benzoate, and this is ethyl propanoate. This one has alpha hydrogens, this one doesn't have. So I'm going to get of course there is a possibility that this will combine it with itself and then this will combine with this. So we always take the one which doesn't have alpha hydrogen in excess. So by taking this in excess, we ensure that the anions of this have a higher chance of meeting this one than meeting one of their own kind. So first I'm going to add ETO minus to this, the strong base, and the ETO minus is going to take out this alpha hydrogen. It is going to turn it into a carbanion. The carbanion attacks, this shifts to O, and then the O minus comes back and this one leaves. So, and then in the end I acidify it to get an acid, and the product that I'm going to get would be this PHCO CHCH3 CO O ethyl group, and plus ethyl alcohol. So this is the product that I'm going to get out of this. And remember, I've just acidified this so that I ensure that I get back the H here. Take one more example. We take again ethyl benzoate, as usual in excess. This time I'm going to use ethyl acetate, and the same set of reagents. I use alkoxide, then I protonate this and I get this product, which we call it as ethyl benzoyl acetate. This is ethyl benzoyl acetate. Let's do one more. We can take ethyl formate, and we take ethyl acetate, and alkoxide, protonate, and we get ethyl formyl acetate, C double bond O, O ethyl, and we call this as ethyl formyl acetate. And we can take the ester of oxalic acid, ethyl oxalate, and then treat it with ethyl acetate. You must try and understand that, you know, we can write esters in many different ways. I can write CO2, someone can write COO, someone can write COO together. So one must also understand that the same reactant can be written in various ways. So that's important. Now if we again use the same set of reagents, ethoxide, protonate this, I'm going to get ethyl oxaloacetate. So that is C2H5, because one reaction occurs here. C2H5O, C double bond O, C double bond O, CH2, C double bond O, O ET. This is called ethyl oxaloacetate. So this is the mixed Clasien ester condensation. Now of course it's not necessary only to use the esters together. We can sometimes use, just want to change the sheet, turn back, and we can even use a ketone and an ester. So suppose I use an ester ethyl acetate and I take this in excess and I treat this with a ketone. I don't do this with an aldehyde, I'll only do this with a ketone. For the simple reason that when I take a ketone, the advantage is that I can get a carbanion here and this can attack this, because the carbanion of a ketone is more acidic than the the hydrogen, the alpha hydrogen of a ketone is more acidic than the alpha hydrogen of an ester because of the releasing effect of the O, and therefore the minus is going to form here and it's going to attack here. If I use aldehyde, the chances of a self reaction is much more. So what we're going to get in this case is when I do with ethoxide, and we should now learn to make the product without using the mechanism. We get the negative here, okay, and this negative is going to attack here. This is going to go up, come back, and leave this. So I'm going to be getting this is the keto group, and on this alpha carbon I have another keto group attached, and I get a CH3 here. This is a beta diketone. This is a beta diketone. Of course one could feel that you know, the minus could form here and this could attack the here, but the chance of that happening is low because this hydrogen is more acidic, and I've already taken this in excess to ensure that I don't get the self reaction of this. So in a similar situation we can take acetone, and acetone can be made to react with ethyl acetate, and the sequence of steps would give us CH3, C double bond O, CH2, CO, CH3. So I get a 2,4-pentane dione. And let's take one last example, CH3 C double bond O pH, and then I do it with ethyl benzoate. The same set of reagents, ATO negative, protonated H plus, and I'm gonna get a beta diketone. We call this as dibenzoyl. Let me write this again, dibenzoyl methane. This is the benzoyl part, dibenzoyl methane. So that finishes the cross Clasien ester condensation. In part 3 we're going to look at the intramolecular condensation, Clasien ester condensation, called the Dieckmann condensation. Thanks for watching.